Am I audible? Hello. Okay. I'm sharing my screen. Let others come. Hope my screen is visible to you all.
No, ma'am.
Okay. Now?
No, ma'am. Or yes, ma'am.
Okay. We'll just wait for some minute and I'll start the class. Let others join. Till then, those who have joined, please give me your attendance. We'll wait for some minutes. Is my voice is clear now? Hello? Okay. 31 participants. So, one by one, okay, write your roll number in the chat box. All of you write your roll number in the chat box so that I can have a track. Roll number will be enough instead of name. Write in the format. Alfred, write in the format. 82L 2018 22 78 like that. Okay. Okay, let's start with the class. I'll just revise the last class introduction class. Some of you might, most of the students didn't join the class, so I would like to just quick revision of the first class. My screen is visible, I guess, right? Hello? Okay, okay. So, so in the last class we studied that how engineering mechanics deals within our day-to-day life, how the physical world works and how the application of science is used to fill the all the human needs. Then in this course we are going to study about the deformable bodies. Earlier in engineering mechanics we studied about the rigid bodies which cannot be moved. Now we will study that how those bodies can be deformed. Then again there is a mechanism, and this subject is the foundation of all structural and machine design. We'll take a engineering structure, then we'll apply the external loads, then we'll find out the internal forces generated in those members due to these external loads. And external loads can be axial, torsion, transverse, or a combine of axial or torsional. Then we'll find out the stresses and strain on those members and we'll decide that it's a how's the structural performance, whether it failed, whether the structure could resist all the loads and all. So this is the overview of the syllabus. Fundamental of stresses and strain and axial loading, then thin wall pressure vessels and torsion, then beam bending, then deflections, buckling, combined loading, failure theories. These are the topics we'll discuss. So the basic emphasis will be on the understanding the principles of mechanics of material rather than extensive computational work. So this is the main lecture of today's class. Today we'll discuss and define what is normal stress and what is shear stress. So, are you guys clear with the axial centric loading? Do you guys have any idea what is axial centric loading? Please respond. Hello? This is the interaction class, so please respond. Am I audible? Hello?
Yes, ma'am.
Yes, so you clear with axial centric loading? Any doubt in this topic? What is axial centric loading? Should I discuss again? Hello? This is the interaction class, so please respond. All of you respond. Should I discuss this topic, axial centric load, or should I move to the next?
Topic.
Sorry?
Next topic.
Next topic. Okay. So hope this topic is clear to you. What is axial centric loading? So we have taken a truss. We applied some external forces. We have applied the axial centric loading. This will be our external load. Now we'll see how this external load affects in the internal forces. Means what happens when we applied an external load. And here our external load is your axial centric loading. So earlier I have taken a member from this truss HG and we have applied axial centric loading. Now we'll see the internal forces. This is the member. Okay. To see how this member has been affected due to external load, I'll cut the section. Okay. I'll cut the sections into halves, in two cuts. This is the transverse cut and this will be non-transverse cut. So let's see the first transverse cut. Okay, this is our transverse cut.
Ma'am, I can see the screen.
Hello? Yes? Screen is not visible?
Can you see the screen? No, ma'am.
Wait. I have to off my video, I guess. Now, is it visible, the screen? Screen is visible? Hello? Hello?
Yes, ma'am. Yes, ma'am.
Okay, okay. Suraj Jamade is requesting to annote the share. Please don't decline. Okay. So this is our section. I have applied axial centric load. This is our P. This is the axial centric load. This is the axial centric load. Now I have cut the section in transverse cut. This is the transverse cut. Now I'll draw the free body diagram of this cut. So here P is applying in this direction. Now I'll analyze what are the forces in this section what are the forces is acting on this surface. So there will be one normal stresses and there will be one shear force. Okay. Now if we see the equilibrium, what is equilibrium? Anyone idea what we do in equilibrium? what we do, we equate the forces. So if we equate the forces, what are the forces in horizontal direction? What are the forces in horizontal direction? Tell me.
P and N.
Yes, yes. So forces in horizontal direction will be P and N. So P will be equals to your N, right? And what are the forces in vertical direction? Only V, right? Only V. Here in this direction there is no force. So V will be equals to simply 0. So here axial centric load is directly equals to normal shear. Here N is representing as normal stress or normal force. Okay, and V is representing as shear. So here N is your normal stress, V is your shear stress. Hope this part is clear. Any doubt in this section? How this P becomes N, how this V becomes equals to 0. Please understand then, because we are going to do a numerical based on this equilibrium. Hope this part is clear. Students, you have to respond. Then only I will know that you are present in the class and I am not.
Only I will know that you are present in the class. Yes, and I am not.
Okay, okay. Okay, then I cut the section. See, this is the simple cut. This is a simple cut and you got to know what are the forces are acting when the plane is straight. You can take it as a straight plane or plane strain. Next, I have cut the section in some incline, in some degree or inclined plane. You can take this section as an inclined plane. So I have cut the section. Let me note. Okay. See, I have cut the section. Now this is the inclined plane. So here normal stress is along the, this is vertical direction, is along this direction, and shear is in this direction. Okay. Why? This is the inclined plane. Normal is acting in this direction, and shear is acting is this direction. So basically normal stress is perpendicular to this surface, N is perpendicular to this surface, and V is parallel to the cut surface. Okay, but if we resolve the forces for this N and V, we have resolved the forces. Resultant forces will be P. Okay, now what will be the forces in equilibrium? This P and this P will be equilibrium or not? See, here forces is in horizontal direction, so obviously we have to take the force here in horizontal direction. How will we find the horizontal direction? By the resultant of N and V. Okay, so this is N, this is V. Take out the resultant of these two forces, this will be your P. This concept will be more clear when we'll do the numerical. For the time being, just understand that in transverse cut, one force will be in along the perpendicular to the cut surface. This is your cut surface. One force will be perpendicular to the cut surface and one force will be parallel to this surface. Okay, now let's move to the more closer view of the non-transverse cut, or you can take as stresses on inclined section, or you can take as plane. This is an inclined shape, right? So you can say non-transverse cut, or you can say inclined plane. So what is normal stress? So basically your normal stress is force per unit area perpendicular to the cut surface. I told you normal stress is the perpendicular. This is your cut surface. This is the surface and these forces are in perpendicular to the direction. So this force divided by the cross-sectional area of this section will be your normal stress. Okay, and this normal stress is represented by sigma. And here we are assuming that the area is, this stress is uniformly distributed. Suppose here it is, let me note again. Suppose wait a second. Okay. Suppose I am assuming here the stress is 50 kilonewton. Suppose I am assuming here the stress is 50 kilonewton. So here also the stress will be 50 kilonewton. Again here the stress will be 50 kilonewton. So uniformly distributed means all over the area the stress will be same. Okay. And the sign convention for positive we'll take tension, and if the answer is in negative then we'll take in compression. Hope you guys concept with this clear. Tension is like this, we are pulling it out, this is called tension, and compression generally represents compressing. The word itself signifies compress. So this will be compression, this will be your tension, this will be your compression. So when you get the stress in negative, so you will understand that the stress is your compression. And when you get this stress as positive value, then you should know, or you will take that it as that the stress is in tension. Hope this part clears. Many students are in waiting room. Is it clear? Any doubt in normal stress? I'll give you a numerical to do itself. So let me know. And those who joined newly, please write your roll number in the chat box. It will be easy for me to track down. Many are in. Okay, this part is clear or not? Hello? Hello?
Yes, ma'am.
Okay, okay. So let's move to the another part. So next, let's move to the shear stress. What is shear stress? So basically, shear stress is force per unit area parallel to the cut surface. So shear stress is, this is your cut surface. All the forces are parallel to the cut surface. See here. All the forces is in this direction. And your cut surface is also in this direction. We have cut the section is this direction only, and all the forces are in this direction. So the force per unit area parallel to the cut surface. So what is the shear force divided by the area of this section will give you shear stress. Also, we are assuming that this force is uniformly distributed over the whole section. So I would like to do, I want you all to do a small numerical based on this normal stress and shear stress. The dimension of the steel alloy is given to you. The thickness is 10 mm, weight is 60 mm, and it is subject to a axial centric load in tension. Remember, the axial centric load is in tension, which is of 60 kilonewton. You have to determine the normal stress and shear stress in both the cases, in transverse case also and in non-transverse cut also. So guys, please try this numerical and give me the answers now. Always sit with your pen and paper when you do the class. Please write down this question, draw this figure, and find out the normal stress and shear stress for transverse cut and non-transverse cut. Let's find out first transverse cut, then we'll discuss this non-transverse cut. Is it okay?
Ma'am, can't see the question, ma'am.
Okay, this question is not visible. Now, worksheet. I have written worksheet. Screen is not visible.
No, ma'am. Not visible, ma'am.
Wait. Now, all of you are getting same problem? Or is it possible?
Can see.
Can't, can't see.
Yes.
Let me do one thing. Let me try once.
Now we can see. I can see.
You can see. Wait. I'm sharing it again. Just wait. Wait. Share content. Hope this is visible now. Is it?
No, ma'am.
Just wait for some seconds. It will be. Maybe due to network. My network is little bit
I can see now, ma'am.
visible.
It's visible now, ma'am.
Okay,
Visual
okay.
now. Yeah.
Okay, okay. Please write the questions and try it once. A flat steel alloy bar has a thickness of 10 mm and width is given to you 60 mm. And it is subjected to an axial centric load in tension of 60 kilonewton. Determine the normal stress and the shear stress in the bar on both the transverse plane and inclined plane. So, first find out for transverse plane. Draw the free body diagram, what are the forces are acting, equilibrium it, and find out the normal stress and shear stress. If anyone find out the answers for transverse cut, please respond. Are you able to do? Till then, I'll mark your attendance. I'll call the names as per chat. You just respond. Okay. Roll number 53. Roll number 53 is there?
Yes, ma'am.
Okay.
Yes,
88.
ma'am.
88. Roll number
Yes,
88.
ma'am.
Okay.
Yes, ma'am.
63. Roll number 63.
Roll number 63.
Okay. 90.
90.
Roll number 90.
Is present.
Okay. 83.
Present, ma'am.
77. 77.
Present, ma'am.
82. 82. So 82 is present.
Present, ma'am.
Okay. 72.
Present, ma'am.
81. 81. 81 is present. 76. 76. Tash, mute yourself.
Mute your
71. 74. 71. 78. 92. 92. 108.
Present, ma'am.
75. 67. 112.
Yes, ma'am.
106.
Present, ma'am.
103. 103 is present. 97.
Present, ma'am.
116. 116. 73.
Present, ma'am.
73 is present. Okay. 70.
Yes, ma'am.
Okay.
Ma'am.
Who said present? 70 or 73? 70.
70. Present, ma'am.
Okay, okay. 94.
Present, ma'am.
66. 107. Vidishmita, 100.
Yes, ma'am.
Okay. 56.
Yes, ma'am.
56. 68. 58,
Present, ma'am.
82,
62.
okay, 68,
Ma'am, 57.
57. Write your roll number. That's why I'll call na. Write your roll number in the chat box. Then I'll call one by one. 56, 68, 82. Your side is not okay. Okay. So 99. I've given you marks, Suraj. Okay. Anyone done the numerical? Anyone got any answers?
Hello, ma'am.
Yes, yes.
Ma'am, 101
What?
Ma'am,
present.
61 also present, ma'am.
61.
101 present.
91
Yes,
present.
ma'am. 61 is present, ma'am.
Yes, yes, I have given the attendance.
101 present.
What roll number?
84.
Yes, I have given the marks. I have given the marks. See, let me know. I'm calling out the each roll number. Just let me know if anyone is missing. 53, 88, 63, 90, 83, 77, 82, 72, 81, 76, 74, 71, 78, 92, 108, 75, 67, 112, 106, 103, 97, 116, 73, 70, 94, 66, 107, 56, 68, 82, 66, 61, 62, 57, 99, 93, 114, 84, 56, 57, 112, 62, 119, 101, 67, 78, 76. Hope it's clear now. Okay.
61 is present, ma'am.
Yes, I've given. I've said my 61. Okay, just tell me the answers.
Okay, ma'am. Thank you, ma'am.
Tell me the answer.
Ma'am, 84.
80. What is the answer? I'm asking the answer. Hello? Hello? Am I audible? Hello? Hello? My voice is audible to you all or not? Hello?
Hello.
Okay. So tell me the answers. How much you got the answers? Hope my screen is visible to you all. Anyone found out the answers? Any answers? Transverse cut or whether transverse cut or non-transverse cut? Any answers? No one. Hello? This is an introduction class. If you have any doubt, you can ask. This is the same class we used to do in the class. The difference is this will be in online base. If you have any issues, if you didn't able to answer, at least response. Is it okay to respond? Hello? Hello?
Yes, ma'am.
Yes, so got any answers? Tried anything?
No, ma'am.
Not tried.
No,
None
ma'am.
of you, 38 students, none of you tried anything. Section A got me so beautiful answers. They tried at least. None of you have tried. Okay, let me share the answers with you all. So see, this is the answers. Okay, so this is for the, forget about the inclined plane. We'll discuss it later on. Just see the transverse plane. So this is a section. When you cut the section, we are taking A cross section area for non-transverse cut at A and transverse cut AT. Suppose AT. AT is the area cross section area of transverse cut. So this is a
Ma'am.
section. Yes. 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 Hello.
It's not visible. Yeah, now it's visible, ma'am.
Screen is visible.
Yes, now it's visible. Earlier it wasn't.
Okay. 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 So this is our section. We have cut the section in transverse cut. So I'm representing the area of cross sectional as AT. Okay. So this is the transverse cut. This P is 60 kilonewton and we have resolved the forces N and V. N is 16 kilonewton. This, if you take as equilibrium, this P will be equals to this P, N. So P is whatever the P value, that will be N value. As if by equilibrium, P is equals to N. So N is 60. As vertical direction there is no force, so V will be equals to 0. So we got our N value. So normal stress is N by A. N is 60 kilonewton we got. Area will be, dimension is given to you, width into thickness. That will, as this is a circular section, so your area will be this width into thickness. So area is 600 kilonewton. So divide this value, you will get your stress, which is in kilonewton per mm square. And if you convert it in, see, the value is in positive, so it will be in tension. That's why here it is represented as T. So if you convert this as in 100 MPa, so this will be your, this is the conversion. If 1 kilonewton per mm square is equal to 1000 megapascal, or you can represent it as MPa. Now you need to find the shear stress. So what is the formula for shear stress? It is V by A. Here V is, shear stress is 0. If A V is 0, so this, the whole terms will become 0. So understood? For the transverse cut, your normal stress is 0.1 kilonewton per meter square or 100 MPa, and for shear stress this is 0. Clear? Hello? Hello? Is this clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. So now again for this inclined plane, just try by yourself. Just try by yourself. Okay? We'll discuss in the next class, but I want you all to try it once. Is it okay?